Lesson 9.2, Simplifying Rational Expressions. Now first and foremost, let's understand that we are talking about expressions. And expressions mean that we do not have an equation in our statement. We just have an expression, so we're asked to simplify. If we have expressions we can simplify, if we have equations we can solve. So in this lesson we're going to focus primarily on expressions, which means our job is to simplify. Okay, now a rational expression is going to be, as mentioned in the previous lesson, we're talking about a numerator and a denominator that are polynomials. Okay, so we're talking about fractions, algebraic fractions. We cannot divide by 0. We learned that in the last lesson as well, because at 0 they're undefined, and that was our asymptotes that we had. So the denominator, or the polynomial in other words, cannot be 0. Alright, so there's some restrictions, and we're going to be asked to find those things. And that, if you remember, is or are called the excluded values. Now again, I do not have my airliner, so I'm going to be typing these things in or using my hand. Alright, so just like last time, I'm going to do this a little bit differently. I'm going to say, we're going to focus on this one here. What are the excluded values? Again, excluded values means numbers that cause the denominator to be 0. So we're only going to focus on that. Alright, so what would cause 18, what would cause 18n squared to equal 0? Well, if we divide both sides by 18, we will get n squared equals 0. If we take the square root of both sides, we will get n equals a plus minus root 0, but we know that that's going to be 0. So n, in other words, in the denominator of this rational expression, n cannot be 0. So 0 is the excluded value. Okay? So n cannot equal 0. If n was 0, it would be undefined. In the next one, again, we're going to focus on just the denominator because that's where the problem comes from. So we're going to ask ourselves, what would cause nv squared minus 2v to equal 0? Well, if you notice, one second here. Okay, if you notice, you have 2v squared minus 2v, which means they have something in common. So let's factor that, and that's going to be a lot of what today's lesson is about anyway. I can factor a 2 out and a v out, and if I do that, I end up with a v minus 1 in parentheses equals 0. Alright, now, what would cause that to be 0? So now we're using the zero product rule. Well, in this case, if I plug in a 0, 2 times 0 is 0, and no matter what is in the parentheses, I'll get 0. In this parenthesis, what would I plug in to cause that to become 0? A positive 1. So we have two solutions in this one, or I shouldn't say solutions. We have two situations, two numbers that would cause the denominator to be 0. 0 and 1. So both of those are considered excluded values, and that means that x cannot equal either of those, 0 or 1. Now, we want to learn how to simplify rational expressions, and there's really two types of rational expressions that we'll see. One is where the numerator and the denominator pieces are being multiplied, and then another one where you have addition occurring, or subtraction. And we have to be able to handle both cases, and they are a little bit different. Okay? When we have multiplication occurring in the rational expression, it's not too bad. We can just go ahead and cancel some things out, and we'll see an example of that. But if you notice, when you have rational expression where you have a numerator and denominator pieces or monomials being added or subtracted, we can't just cancel yet. We actually have to do some factoring. And what this process does is that it creates multiplication problems. So 3 times the parentheses, 4 times the parentheses, because when multiplication is occurring, that is when we can cancel things out. And this brings us to a very important piece of information. For example, if I have x minus 2 over 2, all right, so I have a rational expression like this. I cannot cancel the 2's out. Okay, I cannot do this. I cannot do this because x minus 2 is a subtraction problem, and these two have implied parentheses, which means that when you have addition and subtraction going on, you have parentheses wrapped around those two things, keeping those two things as 1, which means I can only divide by 2, I can only cancel that 2 out if the x and the 2 had a 2 with it, meaning 2x minus 2. Now in that case I could. So for example, if I had 2x minus 2 divided by 2, now in this case I could actually cancel because they all have a 2 in common. And that would leave me with x minus 1. Alright, so you'll see as I go through these examples that when we have a subtraction or addition going on, I have to factor, and then when I factor, I create multiplication situations which will allow us to then cancel. Just like in the first one here, they both have a's, I can just cancel them out. So multiplication allows us to cancel things out, addition and subtraction does not. Very important part of simplifying rational expressions. So let's take a look at the first one, and I'm going to approach this one like Miss D did, and she did a nice job of this one. I'm going to write this out differently. I'm going to say 15, and I'm going to write a cubed. Alright, and then I'm going to go 21, and I'm going to write a. Okay, now what I'm doing is I am separating these two pieces of the fraction. Alright, because I'm going to deal with the 15 and the 21 separately. So 15, I know 3 can go into that 5 times. I know 3 can go into 21 7 times. So I have 5 sevenths. Now I didn't mean to underline the 3 there, sorry. I have a to the third over a. Now that means a times a times a. If I go longhand, that means I would go, whoops, I don't want my underline there. I would go a times a times a, and then below I would just write a, and if you remember we can just cancel these things out. So I would take 1a out there, 1a out there, and end up with a squared. For those of you that remember the rules of exponents, I would take 3 minus 1. 3 minus 1, top minus bottom, gives me a squared also. So our answer would be 5a squared over 7. Okay, and that would be it. Simplified. Again, they're being multiplied, so that's pretty easy. Next one, same thing. I'm going to separate them. I'm going to write negative 6 and then k, and then I'll have 27, so I applied the negative to the 6, and then I'll have k squared. And these are two separate fractions now, and I'll put them back together at the end. So we have this. I'm going to take care of my 6 and 27. Well, I know 3 goes into 6 2 times, 3 goes into 27 9 times, and I have k over k squared. Now again, if you do the rule of exponents, it's 1 the top minus the bottom exponent, so 1 minus 2 is k to the negative 2. Or excuse me. It's k over 2, right? Yeah. K to the negative 1. Now my answer will be 2 over 9, and k to the negative 1 is in the numerator. When you do the property of subtraction for dividing powers here, so that means to make the k positive, it would go below. So that would be our answer right here. Simplified. Okay, Now, we have a note here that's important to understand, that if we're asked to find the excluded values, we're always going to use the original expression, okay, in factored form, to decide what the excluded values are, not after we cancel things, okay, and you'll see that in a moment. Alright, in this one, we have addition and subtraction going on. I cannot just take x's out because of the subtractions. We have implied parentheses with the addition and subtraction. So our very first step is to factor. Now the top one cannot be factored, but the bottom one can. So I go x and x. So factors of 24 that add up to 10. That would be 6 and 4, and they both have to be negative. Now, notice that I can cancel this out and this out now. And the only reason I can cancel that out is because I've created a multiplication problem. Now my final answer would be 1 over x minus 6. But I could not cancel until I factored, so you're going to have to practice your factoring. Now when they say excluded values, it says from the original expression. So in this final answer, I'd say, oh, my excluded value is a positive 6. And that is true, except we have to consider the original expression before we're done. So notice the 6 does come from here, but also we have to consider a 4, because that one comes from this one. So those are considered the excluded values. If you had x equal to 6 or 4, it would cause the denominator to be 0, therefore undefined, and we can't do that. So here's your answer, and here's your excluded values. The next one, same thing. I cannot cancel things out because of the subtractions. These are implied parentheses, which means they look like this. You cannot affect one thing without affecting the other, so therefore you're stuck. But if we factor, and I know that 3 can be factored out, so I get r minus 2 over, now this is a difference of 2 squares if you remember. So again, all these things are coming back to play, so you're still held accountable. So make sure you brush up on those skills. And we get minus 2 plus 2. Remember, these are the nice ones. Alright, now that I've factored, I've created multiplication problems. Alright, so I can cancel out the r minus 2, and I'm left with 3 over r plus 2. That's my final answer. That's my simplified rational expression. But my excluded values are 2 and negative 2. I have to go to the original factored form, okay, of the expression. Here we have 2 more that we're going to have to simplify, and I am going to stop at this point and consider this part A, because I went a little bit slower at the beginning and I didn't get everything done by 15 minutes here. So I'm going to stop at this point, and I'm going to finish this lesson in part B.